Hello, you've joined us. We'll be starting shortly, so please just stand by and we'll get rolling momentarily. Thanks for coming.
I would say Porcelain. I'm curious if I'm not from I mean, there are some sponsors.
If you've just joined us, please mute your microphones. Thank you.
How much do you pay for the oil?
Let's just change the oil, and if I had to fix the brake or something, that's something different.
Oil
For the oil, it's like $55, just the oil.
Hello, folks. If you're just joining us, please mute your microphones. We'll be starting momentarily.
Yeah, premium have include only oil filter.
But you carry still, don't go
I don't
other
go
than here.
Yeah, that's why I'm
Yeah,
like,
then you handle it because it's new, you know?
yeah, if something
If it's
wrong.
old, yeah, they can learn, you know?
Yeah.
Original parts and everything.
Yeah.
If you need some.
No harm.
Hi, Sharon. Can you please mute your microphone?
Sorry about that. Sure.
That's okay. Thank you. Okay, folks, we're going to get started. I want to thank everybody for joining us today for another segment of our famed TTMAC Tech Talks. Before I introduce our speaker, I just want to go through some house rules. Please ensure that your microphones are muted. If you have any questions, please put them into the group chat and we will address them in the Q&A session at the end of the talk. And just to touch base on our TTMAC Tech Talks, if you have any ideas for any topics that you'd like to hear, please email them to our good friend Lisa Weir. She'll be adding her email address into the group conversation so that you have it on hand. All right, let's get rolling. I want to introduce our speaker today, John Alley, who is a TTMAC board member and who also chairs our technical committee for the manuals. He co-chairs that as well. John has been a dedicated professional in the industry for 20 years, and for the past 9.5 years, he has served as a commercial architectural service representative at Custom Building Products. He's a very active member of the industry. We're very, very lucky to have him here today. He's also the director of the Vancouver chapter of Construction Specifications Canada, or CSC. He's a plethora of knowledge, and it's my pleasure to introduce him today, my good friend, our friend John Alley, and I leave you in his very capable hands. Again, if you have any questions, please put them into the group chat, and John will take them at the end of his talk. Take it away, sir.
Thank you, Bader. Thank you, everyone, for attending. So, as the topic is, we're going to be discussing large format tile and large format tile installation. We're going to do this at a pretty good high 30,000 foot level, but as Bader said, if you have any questions, throw them into the chat box and we'll answer them at the end. This is an accredited presentation, so anyone that needs credits, as Bader said, please submit your AIBC or AAA or OAA numbers to Lisa and we'll get a certification of completion out. What we're going to be discussing today is what is considered a large format tile, the importance of surface preparation, different installation procedures, grouting, and movement joints for large format tile. So the industry as a whole, we've moved away from the old 8x8 and 12x12 tiles. We're getting larger and larger and larger. I guess to even take a step back, what is considered a large format tile is anything that has a dimension of 380 millimeters on one side. What we're also starting to see a lot of now, and now that new ANSI standards have come out, are gauge porcelain tile panels and slabs. That's generally anything that has a dimension of 1 meter by square or bigger. It's not uncommon now for us to start to see 24 by 24 as standard size tiles. We're also getting into a lot of the thin gauge porcelains where we're looking at 3 millimeters and larger. Where these products can be used, anything from interior, exterior walls, remodeling tile over tile, obviously new construction, as well as a trend that we're starting to pull into North America that's been quite large in Europe for a while is exterior facades. The tile over tile aspect and remodeling is great, especially from a commercial standpoint. You see it a lot now where elevator lobbies are their carpet's been removed and tiles being put in, and we're not having to deal with a lot of the issues in the past with moving elevator heights or door heights as well. So something to be aware of. Some of the terms that were going to be used outside of the basic ceramic versus porcelain, we have rectified tile. This is tile that's been cut, kilned, and then recut to exact dimensions. So unlike tiles of yesteryear or nominal size tiles where they are cut, kilned, and then that's shipped out, these give the ability to have a lot smaller grout joints and a lot more precise installation overall. We're not having to go with larger grout joints to try and cheat some of the areas in the past where manufacturers used to market tiles as a 12 by 12 or 13 by 13, but they may actually be plus or minus a couple millimeters each way just because of the way they are. We're also starting to see in the industry a lot more color body or through body tiles. This is where the color on the surface of the tile runs through the entire bisque of the tile itself. In turn, we're no longer getting those standard white or gray or sometimes clay colored bisques. It allows the industry and allows the trades as a whole to be a little bit more open with how they're going to finish those joints. Not everyone wants to use a metal or plastic trim. Some people may want to use a miter joint, and having a through body or a color body tile allows that to happen. Glazed versus unglazed tiles. This glazed tiles have a physical surface on them. Usually it's a silica sand that's put onto the body of the tile before it's been kilned, and that's what you're actually walking on. Non-glazed tiles don't have that silica sand added to the surface, and you're walking right on the body of the tile itself. So as the industry has grown and as tiles have grown, there's a lot more importance that's been put into the substrate itself. It's not the old analogy we can just throw more thin set or mortar onto the floor and hope for the best. We really have to look at the substrate, and a lot more preparation has to go into that substrate to ensure that it's going to meet the requirements for installation. One of the big things that we always get asked or to look at is what's your deflection rating on tile or on your substrate. Smaller format tiles, even 12 by 24 tiles, we look at L over 360 as a standard. When we start getting into the larger format tiles, that minimum standard for deflection is now an L over 720. So as I said, a lot more preparation has to go into that substrate. We also have to ensure that that substrate is clean of contaminants and it's ready to bond, whether it being a self-leveler or a membrane or the thin set directly applied. We can't have any bonding agents that are embedded into the concrete. Certain crystalline waterproofing agents work as a bond inhibitor as well. So if products like that have been incorporated into a concrete substrate, how are we going to mitigate that to ensure that we have a sufficient substrate to bond to? We also have to make sure that that substrate itself is sound. On top of the deflection, if it's a plywood substrate, we have to make sure that it's, you know, glued and screwed appropriately for the size of the tile and the thickness of the substrate. If it's a concrete substrate, we have to make sure that there's no voids or hollow areas throughout it. Otherwise, that can lead to possible issues going forwards. So as I mentioned before, a lot more emphasis is being put onto ensuring that your substrate is true. With tiles that have a dimension of less than 380 millimeters on one edge, we can still go with a 1/4 inch over 10 feet or 5 millimeters every 3 meters for how much undulation or height difference you can have on your substrate. When we get into the larger format tiles or the gauge porcelain panels, that now moves up to 1/8 of an inch over 10 feet or 3 millimeters for every 3 meters with no gaps larger than no more than 2 gaps along that straight edge. In turn, a lot more money, as I said, has to be put into the substrate preparation. A lot more money has to be put into whether it's self-leveling, either cementitious base or gypsum base. But these concerns, even though it's a floor flatness, still pertain to your wall ceiling applications as well. So even though you're not getting the same traffic on the wall, obviously no one's walking on walls compared to a floor, it's still prevalent and it's still important to ensure that you're meeting those standards. So how we look at these numbers, and FF numbers get thrown around a lot. These are dimensions, or these are measurements that are done within Division 3. However, they do pertain to how that floor is going to look and what the trades are going to be able to accept. So floor flatness measurements, they're taken in standard intervals of 12 inches. The thing though, and unlike what we see with the straight edge measurement, which I'll talk about next, is they are not taken within 2 feet of any boundary. So whether it's a wall or through doorways or movement joints or isolation joints, they're not being done there. So floors can look very clean and very level and flat when they're tested, which is 72 hours after the slab is poured, but we're not setting tiles 72 hours after that slab is poured. And on average, a concrete slab moves 30% between your FF measurements and when the trades are coming into set tile. So it's still important to specify and include FF and FL numbers, but understand that there's some limitations to how that measurement's being done. compared to what the trades themselves are looking for when they step foot on site. Straight edge measurements, there is no ANSI or ISO or overall standard to dictate how straight edge measurements are being done. However, I don't want to say it's a little bit of a Wild West, but this is how the industry ensures that we're going to be able to meet what we require for those standards, that 1/8 of an inch over 10 feet or 1/4 inch over 10 feet of your floor prior to installation. So there's no min, there's no max numbers. It's a trade walking around with a 10-foot straight edge and generally drawing X's or circles on the floor to dictate where they're going to have to level or where they're going to have to grind down. Straight edge measurements can be done through doorways. They can be done over movement joints. They can be done up to the edge of columns. So the industry continues to evolve. The industry continues to improve, but there are still certain trades and ownership groups and GCs that take it as a bit of a shock when the floor preparation crews or the tile crews come in and go, we're going to have to spend X thousands of dollars to ensure that your floor is flat enough for us to use these large format tile. One of the other big considerations that we have to look at, and this is something that's become a lot more prevalent in the last 5 or 10 years because of how rapid construction has come into play, is moisture testing and moisture mitigation of your substrates prior to installation. There are a couple of different ways to test how moisture testing is going to be done as a whole, but it's something that generally has to be done prior to any final flooring that's going to be installed. Some of the key things that we have to look at for moisture testing and moisture mitigation is ensuring that the HVAC system is turned on, ensuring that the building is, I guess, up to temperature, the easiest way to explain it, because you can do all the moisture testing you want prior to an HVAC system being installed or prior to all of the windows and door frames being installed. But as soon as you turn it on, it can skew numbers. So the 3 major types of moisture testing on how we can do it, we have calcium tests where a block is put over the concrete and then it's encapsulated under a plastic cover. It's left for a certain amount of time, and then that calcium chloride block is weighed afterwards to see how much moisture was in it. We have surface moisture testing done with little handheld, no bigger than a cell phone devices that will read the moisture within about 1/2 to 3/4 of an inch of the surface of the concrete itself. And then we have in situ probes, which are embedded into the concrete themselves. These are great because in a lot of cases, they can be used retroactively throughout multiple months and multiple different phases of an installation to ensure that the moisture within the concrete itself still maintains what we require within the industry. So the first rule of concrete is concrete will crack. It's just a fact of life. I can't think of a single slab that I've ever walked in on where we haven't started to see cracking form. It's just going to happen. So one of the questions that we get a lot is, are membranes required? No, they're not required or mandated. However, the cost of replacing damaged tile compared to what the cost of a membrane is going to be is significantly less. Now, this is a great example here of where you can see a non-linear crack running through the tile installation. I'm fairly confident that if they had put a membrane down prior to this stone, that crack wouldn't have telegraphed through the tile assembly and onto the surface itself. Membranes can cost as low as 50, 75 cents a square foot, up to $2-ish a square foot. It's probably going to cost minimum of $20 a square foot at bare minimum to rip up tile, repair that crack, put new membrane down, put new thin set or mortar down, put the new tile and grout over top. So as I said, is it 100% mandated? No, but it's cheap insurance. The different types of membranes that exist within the industry, the first one being a crack isolation membrane or an ANSI 118.12. These, in a lot of cases, can help prevent minor cracking and minor movement on plane. They are not for non-plane, for the most part, and no membrane can work for non-plane or out of plane movement. But traditionally, they are for cracks that are 1/8 of an inch or less. Natural cracking that happens, they can be used in conjunction with saw cut joints or control joints to minorly move where those movement joints are to bring them aligned with the tile assembly. However, they are not designed to bridge movement joints or saw cut joints and bury them under the surface. It becomes a very large risk reward to try and do that. I've seen projects with great success. I've also seen projects with some great failure where it's just the concrete or substrate is going to want to move the way it wants to move. So best thing to do when laying out movement joints, and I'll discuss it a little bit more right at the end, but bring all the parties involved to ensure that where those movement joints are going to align with the tile pattern and the layout of the pattern, so we can try and minimize where they are and we're not having to cut tiles into it. Now, this is a photo taken out of the TCNA manual, but it's very close to the TTMAC manual of a crack isolation membrane being used to bridge over a crack in a concrete substrate. Most of the time, crack isolation membranes are going to come in 2 versions. We're either going to have a peel and stick version, or we're going to have a liquid applied version being applied over that substrate. You know, this is an example here of a sheet applied. This is another example of an uncoupling membrane that can help go over and bridge those cracks as well. Uncoupling membranes are really unique from wood construction standpoints because they can help a little bit with that lateral movement. Obviously, plywood or wood substrates thermally expand and contract differently than a tile assembly would, so they can help with that lateral movement. Now, lastly, here's an example of a liquid applied membrane being applied over a concrete substrate. One thing that I do want to bring up and make everyone aware of is with crack isolation membranes or any membranes as a whole, depending on the installation, be careful of what type of membrane is being installed, whether it's a liquid applied or a sheet applied product. Areas that have high point loading, areas that have extreme high traffic, it may not be recommended to use a sheet applied product or a compressive membrane. These are traditionally 2-3 millimeters thick, because even as dimensionally stable as they are, you can still see some minor vertical movement as point loading rolls over top, which could lead to issues in the future. So something to be aware of. Next, we have waterproofing membranes, or ANSI 118.10. Similar to crack isolation membranes, these can come in both liquid applied and sheet applied. There are pluses and minuses to both depending on the applications. Some people like one over the other, but these are, for installations like steam showers, for installations like basic showers themselves, pools, these are applied prior to the tile being installed to ensure that we're not going to run into water egress into the substrate or beyond that. There's been a couple of interesting installations over the years where membranes haven't been installed correctly or the wrong membrane was applied, especially with steam showers, and vapor transference has got through and damaged the walls or the substrate behind that. The last major type of membrane that we're going to talk about is an ANSI 118.13 sound control membrane. These are great for wood construction. These are great for clients or stratas that have concerns about sound transference and how those are going to be mitigated within the system themselves. A lot of apartment buildings, a lot of penthouses, a lot of dorms in colleges and universities are using these style membranes to help mitigate that sound transference to other units around. In a lot of cases as well, sound control membranes also have a slight R value to them, so they can work for that thermal break if that's a consideration as well. So installation of large format tile and gauge porcelain panels, there's a couple of different mortar applications that can be done, and to some degree these terms are thrown around interchangeably, but there is a difference between a thin set, what was considered a medium bed or now large format tile or large heavy tile mortar, and your border bed or wet set installation. So thin set applications, these fall under ANSI 108.5. These, generally speaking, are your least expensive mortars. They can only be installed up to a 1/4 inch embedded. These are designed traditionally for your 12 by 12, 13 by 13, 12 by 24 applications. Your large and heavy tile mortars or your LFT mortars, these mortars are designed to be able to go from 30 up to 3/4 of an inch thick embedded. These are great for installations when you're working with natural stone, or as tiles are getting bigger and bigger and bigger, there always is some level of warpage in them, and ensuring that you're meeting your minimum bond coverage of the back of that tile to your substrate. In a lot of cases, the large and heavy tile mortars or the LFT mortars, these are designed to be more anti-sag, anti-slip compared to the thin set mortars. These have a lot more polymers in them. So in turn, there's a lot more bond strength to them. So we can get into these larger format tiles, whether it be floor, wall, ceiling, and have less concerns about those tiles during installation, shifting or moving, as well as after installation through thermal cycling, debonding or delaminating from the installation itself. These installations, generally speaking, are covered under our TTMAC manual 329 and 330 LFT, which can go into a little bit more detail. Why we use LFT mortars, and I briefly touched about it on the last slide, is tiles by nature have some level of allowable warpage within them. It's just a fact of installation during manufacturing, that tiles during the kilning process are going to move ever so slightly. At the bottom of this slide here, you can see what is allowed under ANSI 137.1 for allowable warpage of specific tiles. And this comes into play where with large format tiles and with gauge porcelain panels, we're looking to have a minimum of a 95% bond coverage of that back of that tile to your substrates. As tiles have gotten larger and larger and larger, the industry has had to adapt, especially with the thin veneer porcelain panels, on how those installations come into play. So as I just mentioned, we're looking for a minimum of a 95% bond coverage of the back of that tile to your substrate. We're looking for no voids larger than 1 inch square, and all edges and corners have to be supported. A technology, and this is a photo on the right-hand side of the slide that came from the vinyl industry, is a lot of manufacturers now are making trowels that are not your standard square notch trowels, but are either a half moon shape or a V-notch trowel to ensure that when you embed that tile into the mortar, that all the cones are collapsing and you're achieving that. Also, we have to ensure that we're back buttering those tiles and putting the mortar onto the substrate itself to ensure that we're getting that minimum 95% coverage and proper adhesion. In a lot of cases as well, with the thin veneer porcelains and even the standard 3/8 or 1/2 inch porcelain panels as well, those once are installed, our trades are coming back in and using either a vibrator or a roller to squeeze out any trapped air to ensure that we're meeting those coverages. Also, we're ensuring during installation that all the trowel marks are running the same direction and we're not using those half moon swirls that you would see with a vinyl installation, to ensure that no air gaps are being trapped within the tile itself. You know, a lot of these techniques, a lot of these recommendations have come into play in the last, 5 or 10 years. Unfortunately, a great example of a failure was West Edmonton Mall. The first time an installation was done there of some 5 foot by 10 foot panels. A lot of these standards did not exist at that time, or these recommendations did not exist at that time. And that was an installation where all that tile had to be removed and reinstalled because there were voids underneath the tile. There were some larger gaps and not all the edges were supported, and some cracking started to form almost immediately. Now, here's an example here of some photos that are being done of a mock-up. Different tools are being used as well. to bond these larger format thin veneer panels, that there is a level of flex within these thin veneer porcelain panels, but when they break quite catastrophically. So once again, another technology that we've taken from another industry, this being the window and glass industry, where we're using A-frames with suction cups to move these panels along. Nice thing is we can do installations extremely quickly. You know, a 5 foot by 10 foot panel, there's 50 square feet right there that's being installed, but there is more prep work that has to go into the substrate prior to installation, unlike a traditional 12 by 12 tile. So as I said, here's a couple of photos of some mock-ups being done on a wall. Them ensuring, here's an example of a trade using a roller to collapse those combs and get all the excess air that could be trapped within out. This is a photo of what a minimum 95% coverage should look like, where they've set a tile and then popped it back up to ensure that we're getting those coverages. We're ensuring that all the comb from the trowel marks are being removed. The major types of mortars that do exist, we have our ANSI 118.1 or non-modified mortars. Moving into the modified mortars, so these are mortars that now have polymer, essentially glue into them. The base standard for a modified mortar is ANSI 118.4. We have improved modified mortars, ANSI 118.15. These are mortars that have even more glue into them or polymer into them. We have ANSI 118.11 mortars. These are mortars that are designed specifically to go over plywood substrates. Plywood's always a tough one because of the adhesives that they use to laminate the plywood together, make it a little bit difficult in some cases for thin sets or mortars to bond to them. So we have specific mortars that are designed to go over plywood substrates. In yesteryear, we used to have specific mortars for wall-only applications. Traditionally, or in the last couple of years, that's gone away. Usually most mortars that can be used on the floor can be used everywhere else. There are specialty mortars that have a flexural characteristic within them that can work for crack isolation. Traditionally, these can bridge cracks somewhere between an 1/8 to a 1/16 of an inch. So this comes into play where you may not necessarily need a crack isolation membrane. But as I said before, crack isolation membranes are cheap insurance for what they are. We have complete contact mortars. This eliminates back buttering. This is a dying type of mortar because the industry as a whole has adopted that you need to back butter your tile prior to installation. There are still 1 or 2 products that exist out in the market from all the major manufacturers that mitigate this. But once again, these are styles of mortars that are becoming less frequently specified and less frequently used. We have rapid setting mortars. These are great for single family dwelling where it's Mrs. Jones and she's got a one bed, 1 bath unit. She's tiling her floor, but you know, she's going to have a shower. She's going to have to go to the washroom at the end of the day. It can allow for grouting within 2 to 4 hours. It can allow for moderate to heavy foot traffic within 6 to 8 hours. However, take that with a grain of salt that as tiles are getting larger and larger and larger, we're having less grout joints, and that curing process in some cases can be slowed down because a lot of curing of cement-based mortars is, yes, there's a chemical component to it, but it's an evaporation-based cure, and you're not having that water of convenience being able to escape because there are less grout joints in play. Now, then we have what was called medium bed mortars, now large and heavy tile mortars or large format tile mortars. These can be installed anywhere from 3/32, 3/16 up to 3/4 of an inch compressed. In some cases as well, there are specific designations after mortars. So if you're looking at it, you'll see an ANSI 118.14T or E or H. These dictate, in some cases, workability or how those tile or those mortars have been tested for shrinkage or lippage or non-sag. So good little tidbit to see. From a architectural and specification side of things, you generally don't have to go that deep down the rabbit hole, but if it does come up in conversation or if you're looking at technical the TDS sheet and you see that, now you can understand what they mean. Some non-cement based mortars that we see in the industry. We see ANSI 118.3 epoxies. In a lot of cases, epoxy grouts can be used as epoxy bonding mortars as well. These, where we're seeing these being used a lot more now is for the thin gauged porcelain panels that may have a resin or an epoxy or a fiberglass mesh backer. In some cases, cement-based mortars don't like playing in the same sandbox as epoxy resins on the back of tiles, so you have to use an epoxy bonding mortar to bond that tile to your substrate. Where more of a recent trend in the industry is either some cement terrazzos or resin-based terrazzo products that traditionally come out of either China or the Middle East. In a lot of cases, these products are extremely moisture sensitive. And while some manufacturers will recommend a cement-based mortar, in a lot of cases, it's becoming industry standard that an epoxy-based mortar should be used to bond those terrazzo tiles to the substrate, as epoxy bonding mortars have no water component to it. So we're not adding any moisture into the assembly that could allow moisture sensitive tiles to warp or creep or move or whatever it may be. Lastly, and this is a little bit outside of large format tile or gauge porcelain panels, but we have organic adhesives or mastics. Traditionally, these are not recommended for wet installations or wet applications, and they are not traditionally recommended for tiles over 8 inches because they don't have the bond strength or the anti-sag characteristics of an epoxy or a cement-based mortar. Other considerations that we have to look at for large format tile, or really any format tile installation, is your environmental conditions. From the little timestamp in the bottom of the photo on the right here, this is BC Place in Vancouver, right before the 2010 Olympics. You can see the crew here is working outside, and they've had to hoard and tent and heat all these installations to ensure that we're meeting the minimum standards for ambient and surface temperature. You can't set tile when it's raining exterior. You can't set tile on substrates that don't meet the minimum temperature requirements. There's some slight variation in the industry, but traditionally the minimum requirement is 10 degrees centigrade for installation. Otherwise, the way that cement-based mortars cure and how they're crystallizing, those crystals can't form correctly and you don't get the required bond strength that manufacturers recommend. So ensuring that the areas are hoarded and heated and at minimum temperatures. In a previous life, when I worked for a retail store, we were involved in an installation up in northern BC where the trade went in, set the tile, the heater was turned on. The GC left at the end of the day and turned all the heaters off. We went back 3 days later to grout, and we could still push that tile across the floor because it was in the middle of winter and that thin set never cured up. You know, all of that tile had to come up. Whatever we could save, we could. New thin set had to be applied, tile had to go down, and ensure that those heaters were on so we could meet those minimum 10 degree centigrade temperature minimums. Mortar bed applications, last major type, there's a couple of different ways to do it. We can have non-bonded mortar applications. This is where a cleavage membrane, traditionally a 6mm poly, is being used, a mortar bed going down with a wire reinforcing mesh built in. We see this more so with plywood construction over concrete construction, but something to be aware of. We also have what's considered a wet set installation. Traditionally, these are for large format natural stone rather than gauge porcelain panel, but this is where a slurry bond coat is put down. Your mortar bed is applied while it is all still wet, and then another slurry coat is put down and the natural stone is compressed into the entire assembly. This is how installations were done prior to self-leveling being as prevalent as it is, but to the same degree, these installations are still done today. more so in limited applications. Now, here's a wall application being done over a cement board with large format tile. Now, you've got your either wood or metal studs. You've got your preferably CBU or cement backer board being installed, and then your large gauge porcelain. In the latest ANSI manuals that have come out for gauge porcelain panels, of which the TTMAC is working on a Canadian version of that, they do still show drywall or gypsum board as an approved substrate. However, what we've heard within the TTMAC and generally industry as a whole is there are some very large limiting factors with gypsum-based backer boards for wall installation with large gauge porcelain panels. And true recommendations are to use a cement board for application because their bond strength and their compression strength and their, I guess, holding power, from a lack of a better term, is significantly higher than what a gypsum board would be. Now, lippage is key with these large porcelain tiles. There are specific industry standards for what's allocated or what's allowed for lippage. However, with tiles getting larger and larger and larger, the industry has continued to improve to mitigate possible lippage that is going to exist. And that's why in a lot of cases, we're using these LFT or LHT mortars to help mitigate some of these possible issues. And we're using clip systems to help ensure that all of the edges of where the tiles are butting up are not going to have a lippage to it. As a whole, this is why the industry has moved away from recommending a 1/2 offset of installation, because generally speaking, with large format tile, the way the tile curves is going to be bowed, and it's generally, its high point is going to be in the middle. And if you're doing a 1/2 offset, the low point of one edge tile is going to meet the middle of the other, and you get this weird wave pattern. I've heard trades say that they can unbend tiles. Cool, but no. That's why in a lot of cases, we're seeing a 1/3 offset minimum or a brick lay. From the previous slide, here is what's falls under the allowable lippage within ANSI for different size tiles and different size grout joints. Moving into the last major topic, them being grouts. I'm going to give a pretty high level here on grouts as well, but it is something that is significant. The traditional sanded or non-sanded grout is our ANSI 118.6 standard cement-based grout. Greg, if I can get you to mute your mic, please. Thank you, sir. As I said, these are your standard and non-sanded grouts. These are the #1 classification of grouts that are used within the industry. However, they are the #1 classification of grout that has inherent issues for callbacks and outside interference during installation. They are more susceptible to shading or blotching or staining, both during installation and after. Traditionally, these grouts as well are products that have to be sealed. We have our ANSI 118.7 high performance. This is the next iteration of type of grouts. We have our newest standard, which is ANSI 118.19 organic pre-mixed grouts. This is a new standard as of 2024. And then we have our epoxy grouts. So to give a slightly deeper dive into each classification of grout, as I said, ANSI 118.6 or Portland cement-based grouts. Anyone that's ever been to Europe, anywhere that's ever looked at a tile installation that's older than probably about 100 years old, these are the style of grouts that existed. You walk through any installation in Europe that was done by the Greeks or the Romans or the Egyptians, grout came in light, medium, or dark gray, whatever you wanted, but they were a mixture of cement, water, and sand. Later on, different color pigments were added. However, traditionally, it was very limited on what they were. The first iterations of us as an industry trying to incorporate or make stronger grouts is we would add liquid latex to replace that water component or to go in conjunction with that water component. This in turn would lower the absorption or the porosity of the grout itself, make it a little bit stronger, a little bit more color resistant, but still, as I said, ANSI 118.6, Portland cement-based grouts, they are more inherently susceptible to issues both during and after installation. Where the second generation and when we start moving into ANSI 118.7 or high performance based grouts, this is where rather than having a liquid latex that was added in to either replace, substitute, or go in conjunction with water, we were adding a spray dried polymer that was reactivated when water was added to these grouts. In turn, they made them a lot more durable, once again, a lot more stronger, but not as good as an ANSI 118.7, where in a lot of cases now with ANSI 118.7 grouts, we're removing the Portland cement-based component and we're replacing it with calcium aluminate-based. This is great because it creates a extremely strong cement-based grout, a lot more durable, far less porous than a Portland cement-based grout. And because we're removing that Portland cement-based grout, we're drastically reducing the possibility of efflorescence forming due to the absorption and then evaporation of moisture within the grout itself. Contrary to what Google and the internet says, and as we all know, Google is always right, cement-based grouts are not waterproof. They do allow some level of vapor transference back and forth. And what this photo is showing on the right here is not a bird that had a bad day. This is efflorescence bleeding out of the concrete substrate, a lower end mortar, and the grout itself bleeding through. Yes, efflorescence can be cleaned topically off the surface, but the next time you have a rain and evaporation, that will continue to pull that excess efflorescence, that excess salt out of the grout itself, causing issues. So the latest technology of grouts that have come into the industry, and as I said, ANSI 118.19 organic premix grouts, this is the latest standard that's come out as of January, February of this year. These styles of grouts have been in development in one way, shape, or form for the last 12 years. These are grouts that are pre-mixed from the factory, so you can ensure that they are truly color consistent from one batch to another to another. No water or additives are added to it. They generally come in either a 1 quart or a 1 gallon container. You pop the lid, start grouting right away. You can put that lid back on. In a lot of cases, they could be resealed and have up to a 2-year shelf life. So ideal for multi-phase projects, ideal for tenant improvements, where you want to ensure that you have a color consistency all the way through. These usually now are a urethane based or some hybrid mixture of silicone and urethane mixture. They will not or do not require sealers because of how they are manufactured. They are antimicrobial base product, so they're not going to build or be able to grow mold or mildew or anything like that. They are not a cement-based grout. However, they traditionally install like a cement-based grout, but they perform once they cure out similarly to epoxy. They are not designed to replace epoxy, but they are starting to take some of the areas where traditionally we would see epoxies being used, some washrooms, things of that nature, where traditionally we would see epoxy. We're now starting to see a lot of these pre-mixed grouts being used because of how stain resistant they are and how durable they are compared to a cement base. The only major limiting factor with these products that we've seen is they are not recommended for full submerged environments. They are not recommended for steam rooms. All manufacturers will have their own little recommendations, but traditionally we tend to steer away from that. And we want to see either a high performance, an ANSI 118.7 grout being used, or an epoxy grout being used in those situations. Reasoning behind that is because they can allow vapor transference one way, but once it condenses, it can't come back out. Last major classification of grout are epoxies. Epoxies are either going to be classified as an ANSI 118.3 epoxy or an ANSI 118.5 furan grout. These are traditionally your industrial grade grouts. These are designed for your commercial kitchens, your hospitals, your food processing plants, your vineyards. Are epoxies, which can be used also as a bonding mortar, as I stated before, but you're seeing epoxy grouts also being used in front of houses, in bars. In a lot of cases as well, we're seeing a lot of epoxies being used in a residential standpoint. Epoxies today are not the same monster that they were 10, 15, 20 years ago. In a lot of cases, epoxy grouts and epoxy bonding mortars meet minimum standards for California air quality. So you don't have to worry about clearing out large square footages if it's a TI improvement, because VOC contents can be as low as 5 grams per liter. We also, one of the hurdles that we see a lot in the industry with epoxy, because epoxy is a true chemical cure rather than an evaporation-based cure, is you have to have what's called an epoxy train. So the photo on the left is dictating what that is. You have someone mixing the two component products. You have someone spreading it onto the ground. You have one person packing the joints and addressing those joints, and then you have someone cleaning. So understand that epoxy is a little bit more work from an installation standpoint, hence why trades charge a lot more for it, because they need more than 1 or 2 people to be able to do it. But if you're looking for a bulletproof end-all be-all product, epoxies are going to be your way to go. Last thing that we're going to talk about with large format tile and gauge porcelain panel installations are movement joints. I use the term movement joints quite loosely. However, within TTMAC in 301 MJ, there's, I believe, 11 different types of movement joints, this being expansion joints, control joints, isolation joints, saw cut joints. These have to be included into your installation. Within TTMAC, there is a minimum of every 2.6 meters. There is a maximum of 6.1 meters. And this varies on whether it's an interior application, exterior application, whether your temperature swing is more than 30 degrees, which realistically anywhere in North America, you're going to get a temperature swing larger than 30 degrees from winter to summer, whether it gets direct sunlight. And something that's not necessarily addressed within TTMAC or TCNA, but something to also be aware of is obviously the size of the tile itself, but the color. If you're doing an exterior application and you're using, for sake of argument, a 1 meter by 1 meter porcelain, that's a very dark color. As dimensionally stable as stone and porcelain tiles are, there is some level of thermal cycling through it. There is some level of dimensional change through it. And those darker color porcelains or natural stones are going to thermal cycle larger than, say, a lighter color. So having movement joints more frequently is highly recommended. From a trade standpoint, this is a question that manufacturers get asked a lot from trades going, oh, where should I put movement joints? If it's a new build, if it's a multi-phase residential or commercial, that should be left up to the engineers or the architect on record. It's not the trade's responsibility to dictate where those movement joints should be. However, if there are movement joints built into the substrate, they have to be honored. You know, a photo on the left here shows where a movement joint was buried, and you can see how it's laterally cracked all the way through that tile installation. On the photo on the right here, this is an installation where a movement joint was, or a saw cut joint was placed into the concrete. However, it was made aware that it was not going to line up with the tile pattern itself. So the trade was going to try and move the tile or the movement joint one way or the other and have a tile sitting on top of that. As I said earlier in the presentation, this is a risk reward. It could work. but understand that it's not generally recommended to do that. Now, what we're seeing within the TTMAC and TCNA, and the standard's been existed within Europe for a while, is what are called non-linear movement joints. So these are movement joints that will follow that tile pattern throughout. Now, here's a photo of an exterior wall application where you can see that movement joint running vertically through the application. And that finishes my presentation. I appreciate everyone attending. I can see that there's a couple of questions. So Bader, if you want to hop back on, and we'll run through some of these questions and go from there.
Yes, sir. Thank you, John. So we had one question early on. I'm not sure who asked it. Lisa sent it through. Has anyone seen indent fracture in a thin panel installation I have in glass, marble, and porcelain tiles? That was the question that was posed.
I see we've got a question here from Kevin. The organic growths, is this the same as acrylic? To some degree, yes. I didn't sit on the ANSI committee who came up with the name of this new premix grout. To be honest, I think the name is a better name could have been developed, but in the past, this is where certain manufacturers would make acrylic base, some would make a silicone, some would make a urethane. Now that this ANSI 118.19 premix grout standard exists, it's had to level the playing field, so to say, to achieve the required performance standards that are now dictated within ANSI. So yes, acrylic grouts are the same as the organic premixed. How each manufacturer achieves those ANSI standards is up to them, but we now have those specific standards for this classification of grout. And as I said, these are types of grouts that have existed in the industry for about 12 years. It was only this year that the new ANSI 118.19 classification has come from.
Great question from Kevin Brooks, my good friend. And then we have another one here. For interior tiled areas, if you have a crack isolation membrane installed on concrete substrate, do you still need to align movement joints with socket joints, or can they be aligned with tile joints?
George, it's recommended to still bring that saw cut joint or that construction joint through the assembly. But you can cheat it one way or the other a little bit. That's why when the latest iteration or the last iteration of the 09 3000 TT Mac manual came out, we now have non-linear movement joints. You do see some installations where a tile is bridging over a movement joint or saw cut joint, and they silicone the other side. It is a risk reward. But generally speaking, it's recommended that where there are movement joints or saw cut joints, whatever it may be, to honor those through the assembly. Sylvie, I see that you want to add in a comment in regards to the acrylic grout. I'm going to let you to hop in and add in your 2 cents.
I'm going to answer that and say yes to Kevin's question.
Sylvie has a fantastic ability, and I always appreciate in her input because she can use 3 words when I'll use 400. So thanks, Sylvie.
That was definitely 2 cents. Fantastically done. The question on top
from a
that we had.
Sorry, okay, then I'll further that. From a manufacturer that manufactures an acrylic grout, I'm going to answer that and say yes, we do meet that standard.
Okay, thank you, Sylvie. The question posed earlier, John, sorry, was, has anyone seen indent fracture in thin panel installations?
I've seen installations, and this is before, I guess, kind of a lot of the major recommendations have come out of play, where there was some voids in these thin veneer panels, and high rolling point loads were present, and little like loony size holes were punched into the tile because the void was underneath. Physically indenting, I think I've seen photos, but yeah. I've never physically seen it myself.
I think it would be very hard to get one of these type of indent fractures in a panel, just based on the characteristics of the actual panel itself. To your point, though, back in the day when people would spot bind these panels, you could get fractures from the void behind the actual tile itself.
Very true. And you know what, Bader, that brings up a good point that I completely missed within the presentation that I should probably bring up. With any large format tile, or realistically any tile as a whole, spot bonding is not, I repeat, not an acceptable form of installation. You know, you have to meet that minimum 75%, but with large format tile or gauge porcelain tile installations, you have to meet that 95% bond coverage. Spot bonding will not get you to that 95% bond coverage. No ands, ifs, or buts. You have to back butter the tile. You have to have coinciding trowel marks on your substrate to meet those 95% bond coverage, to ensure that you've got those no voids larger than 1 inch square. All the seams and edges and corners are all supported. So thanks, Bader, for jogging my memory.
No problem. Hence TT Maxx
that's
Say No to
definitely a big one.
Spot Bonding campaign. You might have seen our little flyers around some of our ad campaigns. Are there any other questions? If not, I want to thank our good friend John Alley. That was a fantastic presentation with a lot of information. My name is Bader Salhia. I chair the Tech Talk Committee at TTMAC, and I'm also a board member. And I would like to invite you to, at any point in time, reach out to us with any ideas for tech talks that you'd like to see, covering topics that you would like us to discuss with experts from the industry. We'd like to gather as many experts as we can. If you yourself would like to have an idea that you might want to present and you have a specific expertise in the field, please reach out to us. We're very open to any information. We appreciate everyone's attendance today, for taking the time to attend. And I wish you all a fantastic day. Thank you again, John. Fantastic work, my friend. And all of you have a great day. Enjoy the fall. Thank you.
Thank you, everyone.
John, I guess Lisa.